Hello, welcome to my video on GCSE Edexcel statistics. We're looking at a higher tier paper. Now this paper is a sample assessment paper, which means that the examiners have written it to give you an idea of what you could be assessed on. So it's very useful to make sure that you can do all the techniques in this paper confidently. As usual, it's got the normal formula page that we'll be referring back to. And it's going to have a series of questions, just like any other exam. Question 1. The table gives information about the water resources and populations of 7 countries in 2000. So we've got the country down the side, we've got the resources that it has. Write down the name of the country that had the biggest population. Okay, so we've just looked for population, which is here, and we look for which one has the highest number, and you can see that it's South Africa. So you're going to write that down as your answer, South Africa. Write down the name of the country that had the largest amount of renewable freshwater resource per person. So we look for that comment, renewable freshwater resource, and it is per person already. So we look for the highest number here, and we look down, and it's Somalia. Okay, so we write down Somalia. Part C. Write down the 2 names of the countries that could supply all of their shortfall in fresh water from wave-powered desalination. Okay, so look for wave-powered desalination in our table, and here it is, wave-powered desalination, and we're looking at if they can cover their shortfall. So if their shortfall is, say, 100%, if they've got the 100% covered, they can cover their shortfall. If they've got less than 100%, like here, they can't cover the whole 100%. If they've got less than 100% like here, they can't cover it. If they've got more, like here, they can cover it. And hence our 2 answers are Antigua and Somalia. Okay, Antigua and Somalia. Let's write down our answers. Done. Okay, so reading off the table, bit of a tricky one on part C, but moving on now. Question 2. The table gives information about the average body mass and average brain mass of 10 mammals. We've got the human in there as well. Look at us going there with our big brains. Anyway, let's not brag, let's just do the statistics. These data are shown in a scatter diagram. Okay, so we've got all the points plotted. And which one is that anomaly right up here? That looks like humans to me. Okay, what are we going to be asked? Horses have an average body mass of 520 kilograms and an average brain mass of 640. Okay, and so let's plot this new information on the diagram. So 520 kilograms and 640 kilograms. So what we're going to, 640 grams obviously, be a massive brain. So we're going to take the data across, and we're going to draw it in with a cross. Okay, so first of all, let's figure out our scales. At the horizontal axis, we've got 5 little squares to get to 200. So you could do on your calculator 200 divided by 5, which is going to give you 40, so you know that each time you hop up 40. Okay, now that's what we're going to have to use when we're doing 640. So we're on 600, we want another 40, and that gets us to 640, so our point is going to be on this line somewhere. And for the body mass, we want 520 kilograms. Well, okay, that's fantastic. It's going to go off the end of the graph, but never mind. Good job this wasn't an actual exam that people had to sit. It goes up to 520, so we just have to go off the side because we can see here our scale is 20, 40, 60, 80, 100. It does only have to go off by one square, but that's really not ideal if you were sitting in an exam. If something like that does happen, it really shouldn't, but just do your best considering. So we just had to go off the side there. Okay, drawn off point. Write down the name of a mammal that does not fit the overall pattern. Well, we already talked about that when we first looked at the scatter graph, because this one stands out a mile. And let's just check that it is us. Okay, that it is us as in humans. The human brain mass is 1320. Okay, so that does look just about right, because 1240, 1280, 1320, bang on. Okay, and you'll find if you go down, you're going to get 262 down here. Anyway, so that's it, it's a human. We'd already thought about that. Ignoring the mammal in part B, so we ignore the anomaly, the human. Draw by eye a line of best fit on the diagram. Okay, so we can ignore that point that we've circled and highlighted. Look at all these points, and let's try and draw on a straight line with your ruler through the middle of all these points. Okay, so try and be thinking about where your ruler is going to go. You can move your ruler around to try and fit the same number of points above as below. And I reckon that we're going to have something like that all the way across. Part II. For these data, describe and interpret the correlation. So, the correlation is going upwards as we go from left to right, and we need to think in terms of brain mass and body mass, ignoring humans because we're special. Okay, so basically, as the body mass increases, the brain mass increases in general, but we are very, very different to that, aren't we? Because we're very clever and we're not massive. Okay, like to see us next to like a whale or something like that. Anyway, don't want to diverge too much. Right, first data, describe and interpret. Positive correlation. In general, as the mammals eventually body mass increases, so does its brain mass. Okay, a pig has an average brain mass of 400 grams. Using your line of best fit, estimate the average body mass of the pig. So we're looking for 400 grams in brain mass. Okay, brain mass over here, 400. So let's go across to our thing, line of best fit. Let's go down, and so we need to just figure out what that number is, where this number's at. We said we're going up in 20s, 220, 240, 260, 280, so it's 270, bang in the middle. So 270 kilograms. A mammal has an average body mass of 600 kilograms. Estimate the average brain mass of a mammal. So same thing but going the other way around this time. We're starting from the mass at 600. Oh, this is fantastic, isn't it? It's gone right off now. Okay, never mind, we're just going to have to draw it on ourselves. So, 520, 540, 560, 580, 600. It's not going to be ideal because we've had to adjust some things ourselves. Let's extend our line of best fit so it keeps them going, and let's just read off as we would have done before if it was actually on the graph. Okay, so we go up to there, read off to the side there. So I reckon here you would be using a ruler, being a bit more accurate. So we've said each little square is 40, so this is going to be 760 because it's one down from 800, so 760 is your answer here. 760 grams. Give a statistical reason why your estimate might be unreliable. Well, for one, we had to go off the side, but statistically, what's going on? Well, what's going on is all our data, the biggest mammal that we had was 460 kilograms. So the biggest mammal we had before was 460 kilograms. We've gone beyond that. We don't know what's going to happen to the data apart from in the area that we have the data from. We can have a good guess there. So this is outside of the data set, so that the posh word for that is extrapolation is needed. So just write outside the data set, extrapolation is needed, unreliable. Okay, totally misspelled unreliable there. So, moving on. Question 3. The local council is planning to build a new swimming pool. The councillors want to get the views of local people. Councillor Green wants to take a census of the population of the town. Give one advantage taking a census. Well, one advantage is that you get the opinions of the whole population. You don't have to just pick a few of everyone. Brackets, whole population. So that's good. Part 2. Give one disadvantage of taking a census. So it's going to be time consuming, it's going to be expensive and quite difficult to do. So carry out. Okay. Councillor Smith suggests taking a sample from the people who attend local sports centre. The key thing here is where he's choosing to take it from. Explain why this would not represent the whole people of the people in the town. It's biased because you're only asking active people or people who already take part in sports. So they probably are going to want a swimming pool, which is what he's asking about. Okay, so biased, only asking people that are already interested in sports. So it's not fair, really. Spelling isn't doing a great job today. Okay. Councillor Singh suggests taking a simple random sample of 100 people. Describe in detail how the council could take a simple random sample. Well, first off, they would need a list of everyone in their population. Okay, so that is what we call a sampling frame. In population, we'll show off we know what it is. We would then number all the people in the list Use a random number generator to select 100 different random numbers from these and select the people associated with each of these numbers. Okay, done. The council decided to use either a face-to-face interview or a questionnaire. So we've got two options. Write down the advice that you would give to the council, explaining the advantages and disadvantages of each method of data collection, the main features of a good questionnaire to use when collecting data. Okay, so let's say face-to-face interviews are good because the interviewer can explain any confusing stroke difficult questions that are not understood. However, an interviewer might influence what the person being asked says, so people may feel more comfortable with a questionnaire and feel like they can be honest and give their own opinion. Okay, so I've given some good and bad points. Questionnaires are also cheaper and quicker and easier to carry out. That's kind of the first part of the question done. We've written quite a lot for the advantages and disadvantages. Second part, we want to describe the main features of a good question to use when collecting data. So, a good question should not be biased. It should be clear and ideally have response boxes for the person being asked to choose from. Okay, so I think we've given lots of information there, more than enough, especially just for 4 marks. So moving on. Question 4. In a series of air races, the pilots were awarded points based on their final position in each of the 10 races. Paul is awarded 8, 9 or 10 points in each of his first 9 races. In his final race, he makes a mistake and is awarded 0 points. He wants to work out his average number of points. Write down one advantage of him using the median. Ooh, well, if he uses the median, 0 won't come into it, will it? Because your numbers would be ordered 0, 8, 9, 10, and you would just find the middle of those numbers. So it would be the middle of 8 and 9. Didn't want to highlight that, I wanted to cross it out. So it would be the middle of 8 and 9. So that's an advantage for him. The score of 0 would be ignored. So he's got to be pleased about that, surely. The range of Paul's points is 10. The range is not a fair measure of spread for his points. Write down another measure of spread that he could use. Okay, well there's a couple of options for measures of spread. You can use the standard deviation or the interquartile range. Probably interquartile range will do the trick. Write down one advantage of this new measure has that the range does not have. So this is not affected by outliers, stroke extreme values. Okay, done. Question 5. Some people are asked which one of the 3 newspapers they prefer: Sun, Daily Telegraph, The Times. And the results are given by gender. Complete the table. Well, that's not too difficult. With totals, that just means add up. So add up the first row, which will give you the total here. So 45 plus 34 is going to give you 79. Next one, 11 plus 10, 21. 10 plus 7, 17. And now the total down at the bottom would be the sum of these 3 numbers. So 79 plus 21 plus 17, 117. Now hopefully we get 117 the other way when we add down the columns and then across. So this time we're going to add down the columns. Let's just highlight to show you exactly what's going on. Down these columns, 45 plus 11 plus 10, and that gives us 66. And then 34 plus 10, 44 plus 7 is going to be 51. And you can just check that 51 plus 66 gives you 117. So that's quite a nice little check to show you're probably on the right track there. Write down the 2 variables used in this table. Well, what is the data we're looking at? We're looking at males and females, which is gender, and we're looking at what papers they read. So that's our 2 bits of data we're looking at, our 2 variables. Easy as that. One of these people is picked at random. Write down the probability this person is a female who prefers the Times. So let's find the person who's female who likes the Time. There's 7 of them. And out of how many? Well, the total number of people is 117. So your answer is going to be 7 over 117 for 1 mark. Given that the person picked is a male, write down the probability he prefers the sun. So we only care now about people who are male. We can forget all this data on females. Don't cross that out in your real exam. But we only care for this question about the 66 males. So whatever we decide is going to be out of 66. So how many of these 66 like the sun? 45. Okay, so it's 45 out of 66, which if you want you can find as a decimal by typing it into your calculator, and you get 0.681, with the 681 reoccurring, so it would be another 681, etc., carrying on forever. So we would say 0.682 to 3 decimal places, but to be fair, probably just leave it as a fraction, safer and more accurate. Question 6. The speed of 100 cars passing a certain point on a motorway were recorded. The table gives some information of these speeds. So we're using S to mean speed here, and what we're looking at is 100 cars. So for a speed of between 40 and 60, there were 15 cars, because frequency is how many. The speed limit on the motorway is 70 miles per hour. Work out how many cars were exceeding the speed limit. So we want to know how many cars went faster than they should have done, faster than 70 miles an hour. If they're in this category, They could be going 70 or less than 70, so we'll let those guys off. But anything past this line, they're going too fast here, too fast, too fast. So it's all these people. So it's going to be 20 plus 17 plus 19, which is going to give you 56. Okay, so 56 people breaking the speed limit. State whether there were more cars exceeding the speed limit or more cars within the speed limit. Okay, well, we started with 100 cars, so that's pretty obvious. 100 cars in total, 56 speeding, so it's got to add up to 100, so 44 not speeding, so more cars exceeding the limit than not. Not good. Not good at all. Some of the data from the table are represented on the histogram. Use the table to complete the histogram. Okay, so let's look what we've got. We've got frequency density, and we've got a value here that we could have a look at, and we've got speed miles per hour. So let's try and figure out our key. So if we're going up, it's going up in 0.2 at a time. 1, 1.2, 1.4, 1.6, 1.8, 2. This is between 0.8 and 0.7. So this is at 0.75. Just a handy thing that we're probably going to need. So looking back at our table, we can see the frequency F, and we know, because I tell you every single paper we do, that frequency is the area of a histogram. Along the bottom we've got how wide our class width was, and up the side we've got our frequency density. Now this is why I just worked out frequency density, because it was 0.75, and if we know our class width, which is easy to figure out because it's between 40 and 60, 20, between 60 and 65 is 5, 65 and 70, 70 and 75, and then 80 and 100 is 20. So basically, if you do class width times frequency density, we should get 15. So you can test it on your calculator. 20 times 0.75, yes. Okay. This one is going to be 12 divided by 5 to get our frequency density, and we're going to have 2.4, but we could have read that off the diagram because it's already there. Next one, 17 divided by 5, which gives us 3.4. The next one, 20 divided by 5, which is just 4. The next one, 17 divided by 5, which is 3.4. And the final one, 19 divided by 20, which is going to give us 0.95. So we're going to have to use this information, put it onto the table. I've copied across our table so that we can see it on the same page. Yours would be on a double spread, so you wouldn't have anything to worry about at all. And we're going to complete the bars that haven't been done. We can see we've done 3.4 here, between 65 and 70. First one we're going to do ourselves is between 70 and 75. That's going to go up to 4 frequency density. That's a circle, we probably don't want that. So let's get ourselves a square, much better. Might get a bit confusing. Okay, so we go up to 4, job done. Next one, we go from 75 to 80 and we go up to 3.4. So between 75 and 80 up to 3.2, 3.4. There you go. And the final one, between 80 and 100, goes up to 0.95. So 0.95 is going to have to be right at the top of here. Okay, it's quite a tricky one to get just right, because look, 0.2, 0.4, 0.6, 0.8, 0.9 and a little bit more for 0.95. Done. And that's for 3 marks. D. Estimate how many cars were travelling at between 60 and 68 miles per hour. So let's look on the graph where we're interested in. Between 60 and 68. Well, we haven't got 68 on here. It's about there. Okay? And remember that we said frequency represents how many are in the bar. So in our second bar, we've got 12 people in there. That's fine. But for this third bar, there's 17 people altogether. But we don't want all of them because we want to cut it off at 68 instead of at 70. So what we actually want to do is just go up to 68. So this is why it's an estimate, because it's not going to be perfect. The key thing to think about here is what's going on with the scale. So I want to zoom in that area slightly for us. So imagine you're on 65, 66, 67, 68, 69, 70. Now it doesn't actually matter how high up your bars go, okay, because what I want to show you will still work anyway, even if they're longer. So can you see that the area that we want is all this side of the line? Okay, we don't want that stuff. So effectively on my zoomed in version, we want from 65 to 68. Now these big rectangles have been split up between 1, 2, 3, 4, 5. So as a fraction, we want 3 out of 5. Okay, so to get how many people in there, it's going to be 3 out of 5 of 3/5 of 17. So 3/5 times by 17 on your calculator, and that's going to give you 10.2. Now be careful when you give your answer, because strictly speaking, yeah, we want to know this area plus this area. So it's going to be 12 plus 10.2. But do not be too quick to write that down. 12 plus 10.2. That equals 22.2. Now can you have 22.2 cars? Not really, that's going to be quite difficult. So if you wanted to, you could say 22 cars. Okay, so let's just write that down. That should be an equal sign. 22 cars. Okay, for 3 marks. Question 7. A council wants to find out about views on recycling. The council wants to know if there is a difference in support for recycling between males and females, and between people aged 25 and under and over 25. Write down 2 suitable hypotheses for this information. Okay, so the first one is going to be about males and females. So what can we predict? We can say that males are more supportive about recycling than females. That's one estimate. And a second one could be about ages. Okay, so people over 25 are more supportive about recycling than people younger. You could say than 25, I guess, as well. Okay. Right, let's move that up slightly. B. Use the best word from a list to complete the sentences below. Age group is, and we've got to choose qualitative, primary, quantitative, secondary, ratio. Okay, well age is a number, So it's quantity, so it's going to be quantitative. Let's write that down. Quantitative. Gender is qualitative. Qualitative. Okay. Because it's not a number. Here are two sampling frames the council could use. A. List the names in the telephone directory. B. A list of residents in one street. Suggest a possible disadvantage of using each of these. So not everyone has a telephone or a home phone. So the whole population are not in the directory. So unfair. That's the first one. It may not be a big enough sample if it is a small street. Okay, so that's that done. Next part. The council would take a systematic sample of 1,000 people from a sampling frame of 100,000 people. Describe how the council will do this. Okay, so first of all, let's think how many they're going to count. So if you imagine all 100,000 people in a list, first thing we're going to have to do is number all the people 1 to 100,000. Okay, so each person is associated with a number. Now we have to figure out how many people we're picking. So we're going to pick a selection, and we're going to do it at regular intervals. So if there's 100,000 and we want to pick 1,000, we're going to do 100,000 divided by 1,000, which should give us 100. So that means that we're going to pick every 100 number, every 100th number, i.e. we pick 100th, we pick the 200th, we pick the 300th, all the way up to 10,000th, which will mean we have selected 1,000 samples. People for our sample. Question 8. The box and whisker diagram gives information about the room occupancy rates percent-wise of 15 resorts in Yorkshire during 1999. Write down the median room occupancy rate. We can see bang in the middle, it's 50. So 50% because occupancy is going across. Work out the interquartile range. Well, that's going to be your upper quartile minus your lower quartile. Okay, so we're going to figure this out by thinking about scale. 45 to 50, it's just going up in ones. That's nice for a change. So that's going to be 54 minus 46, so IQR is going to give you 8. 54 minus 46, 8. 8%. A normal distribution is suggested as a model for the room occupancy rates in Yorkshire in 1999. Give a reason which supports this choice. Well, let's look at it. If we look in the middle, it looks very symmetrical. Okay, so that is a reason that supports the choice. The data is symmetrical. The data looks symmetrical. It's not perfect, but it's going to be close enough to suggest it at least. During 2006, the room occupancy rates percent-wise for the same 15 resorts were, and we've got a list of numbers. For 2006 room occupancy rates, find the median. So median is a middle number. Before we can do that, we must put our numbers in order. And they start to look like they're in order, but then you jump to 61 and go down lower. So they're not. But the lowest is 50, so that's kind of trying to trick you, I think, a little bit. Next one, we've got 51. But then we've got 52. Can I get a 53? Nope. Next one, we've got 54. Next one, we've got 55. And again. And again. And again. We've got 4 of them. 5 of them even. Lots of 55s. And then we've got 56. And then we've got 61, 65, 66, 69, 69. Now because we know there's 15, it's worth just checking. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Right, I usually show you the cross-out method. I'm going to show you one that I'd probably do personally, which is that the middle of 15 numbers you can get by doing 15 plus 1 divided by 2. So 16 divided by 2 is the 8th number. That should make sense because if you've got 7 numbers on one side, 7 on another, that's 14. With 1 in the middle, that gives you 15. So the 8th number, 1, 2, 3, 4, 5, 6, 7, 8. So 55% is our median, the middle number. Now for the interquartile range, we cross that off as our middle. And now we want the middle of the numbers that remain for the lower quarter and the middle of the numbers above for the upper quarter. Okay, so the middle of these numbers, let's do the cross-off method now. I won't actually cross them off completely so you can still see what's going on. 54, so your lower quartile 54, upper quartile, middle of these, above. Okay, so let's cross off. And we've got 65. 65 minus 54 gives you 11. So 11 is your interquartile range. Describe the skew. Very, very interesting. So let's just get ourselves a little idea of what's going on. So in the middle we've got 55. And then if we were doing a box plot, the lower quartile is very close, 54. And the upper quartile is up here, 65. Now I keep banging on about this test that I do, where I draw a big P and see if it fits on to the bar, to the box plot. We have to turn it round, and that is the P shape, bang on. Okay, so it's positive skew. So you write that down. Positive skew. E. Compare the distribution of 1999 room occupancy rates with the distribution of the 2006 room occupancy rates. Let's look back at what we had. Here, that data is symmetric. We've just said we've got positive skew. Interquartile range before was 8. So we can say that straight off. We can say that the interquartile range is larger now. Okay, and the median is 55 now, and before it was 50. So the median is higher in 2000 and was it 2006? 6 than in 1999. The interquartile range is larger in 2006 than in 1999. And we can also talk about skew as well if we want. The skew was symmetric. And the skew for 2006 is positive, which we've just said. Okay. Question 9. The table shows the quarterly index of wages from the third quarter of 2004 to the third quarter of 2007. The year 2000 is the base year for the index numbers. That means that the year 2000 we set the base as 100. So let's just make a note of that. Very important. These data are plotted as a time series on the graph above. The 4-point moving averages, except for the last one, are also plotted. Calculate the last 4-point moving average and plot it on the graph. So the last four numbers, 127, 126, 140, 123, there's 4 of them, so add them up, 123, add 140, add 126, add 127, divide that by 4, and you get 129. And it wants us to plot it on the graph. Okay, so it's got to go in the middle of those 4 numbers that we just talked about, but you can see the pattern that it goes 2 along each time, so that can help you know where it has to go as well. So it's going to be, what was it? 129. It's going to be here. It's going to be here. 129. So scale isn't very clear. 130. 129 is there because it's just going up by 1 each time. Okay. Draw a trend line on the graph. So a trend line is going to go through as many of these points as we can. Try and get it bang in the middle of the moving average points. Okay, so let's put it on in a nice red colour. Now we're going to start it as early as possible and go right to the end. So I know what these questions are like these days. They might ask us something else after. Done. Write down the quarter in which the wages were at the highest each year. So can you see the peak of the graph as it goes up each time? Highest, highest, highest. Which quarter is it? 1. Every single time. Okay, so it's the first quarter. The average wage was 18,000 in the year 2000. Taking 2000 as the base year, use this information in the table to work out the average wage in quarter 1 of 2005. Okay, quarter 1 of 2005. So quarter 1 of 2005 is here, and we want to work out the index. It's here, so it's 128 as we read off. So let's sort these out into years. So 2000 comes first, and we started off with an index of 100, and then 2005 our index went up to 128. But what we're really bothered in is the average wage. So the average wage was 18,000, and that was corresponding to 100. So we want to know what 128 corresponds to. Well, the trick is, how do you get from 100 to 128? You may even be able to do this in your head, because you can times by 1.28. So if we times 18,000 on our calculator by 1.28, we are going to get the answer of 23,040. Job done. Part E. Work out the average seasonal effect for quarter 1. Give your answer to the nearest whole number and show your working. Okay, average seasonal effect. Let's have a look at some of the trends. So 1 has gone right up there, up here, and up here. We want to know exactly how much each one has gone up by, and then we want to find the average of those. Okay, so the difference between this point and the point here. So 119, and we've already said this one, 128. So 128 minus 119 is going to be 9. So that's our first number we're interested in. Next one we're interested in is from here, which is 123, up to here, which is 133. So that's a difference of 10. That's the blue line. This one we've gone from 128 again, up to this time 140. So that is a difference of 12. So we want the average of 9, 10 and 12. So add the three of them together, 9, 10 and 12, and then divide by 3. So that should give you 9 plus 10 plus 12 divided by 3. 10.3 reoccurring, or 10.3 nearest whole number, okay, 10. Make sure you read the question. F. Predict the value of the index of wages for quarter 1 in 2008. Okay, so we're estimating that each time quarter 1 is about 10 on average above the trend line. So wherever the trend line is here in 2008, we are going to go 10 above the trend line. So here's quarter 1, and the value that it's on is, I'm going to read across, 133, and we want to go up 10 to 143. Okay, it's around there. So that's where we reckon it's going to be, 143. What's your answer? 133 add 10. 143 we think the index will be. Question 10. JLD Engineering is supplied a part from 2 different companies. 70% of these parts are supplied by Company A, 30% of these parts by Company C. The quality of the parts supplied by customer A, Company A, is 97% and 3% bad. Quality of the parts supplied by C is slightly worse, only 95% are good and 5% are bad. First thing we do is complete the tree diagram. Each strands have to add up to 1. So if we've got 0.7 here, we need 0.3. If we've got 0.97 there, we need 0.03. We've got 0.05, we're going to need 0.95. And we get these answers by multiplying along the branches, and you can always check yourself. 0.7 times 0.97 on your calculator gives you 0.679. Next one, 0.7 times 0.03 gives you 0.021. Next one, 0.3 times 0.95 gives you 0.285. And the last one, 0.3 times 0.05. It's going to be quite small, 0.015. Okay, 2 marks. A part is selected at random. Work out the probability that the quality of the part is good. Well, where are the good ones? Good ones are here, and the good ones are here. Okay, so it's this probability, add this probability. We can show working out. So let's do that now. 0.679 add 0.285, and we're going to get 0.964, which is quite likely, very likely. Okay, a part is selected at random. Given that the part is good, work out the probability that it was supplied by company A. So we already know it's good, okay? So we already know that it's in here or here. So we do not need to worry about the bad ones. We don't need that, we don't need that. And we've already added these two up. So the probability, instead of being out of everything, is just out of that, 0.964. Okay? Now we want to know how many of those were supplied by company A. So let's have a look back and see how many were supplied by company A. Well, what proportion? So company A is up here, so 0.679. So that's going to go on the top of our fraction. On our calculator, 0.679 divided by 0.964 is going to give you the answer of, it's a long decimal, 0.7043568. It still keeps going. We're just going to give it to 3 decimal places. The 3 doesn't change the rounding, so 0.704 for your answer. Question 11. The comparative pie charts give information about the number of people living in 6 continents of the world. So in 1980 and 2007. What has happened to the total number of people living in the world in 1980 compared to 2007? So what's changed here? Explain how you can tell this from a pie chart. Now what you can tell is that, if you've got good eyesight, is that this pie chart is actually bigger than the other one. Okay? Not by much, it takes a keen eye, but it's a bigger pie chart, so you know that the number of people has increased. So let's put that in words. The number total people has increased between 1980 and 2007, since the area of the pie chart has got bigger. Now comparative pie charts, so that's what they do. The area represents how many are in there. Write down the name of the continent with the greatest increase in population. So what's gone from having a relatively small area to a bigger area? Which has got more increase? Okay, so it may look like the white one, or it may look like Europe. So we've got to decide Asia or Europe. So thinking back to the shape that we drew, this circle, it looks to me like for Asia the area stayed, the angle has stayed quite similar, but we're getting all this increase around the edge as well, plus only a % increase there. So what you're thinking is that little slice of Europe that's increased here, is that bigger than all around the edge? And I think you'll find that it's not. So the area that's got more extra area is to Asia. So that's your answer. C. Describe how the total number of people living in Oceania has changed in 1980 compared to 2007. Explain your answer. Well, it's the same percent, 0.5. However, the pie chart's got bigger, so that represents more people. Okay, so more people living there. The percent has stayed the same, but the total number has increased since the area is larger. The area of the pie chart, I mean, not the area of the place. Question 12. The table gives information about the age and the minimum stopping distance at 40 kilometers per hour for 10 cars. Okay. Work out Spearman's rank correlation coefficient for this data. So, what we're going to do is we're going to write out the Spearman rank formula. If you don't know it, it's at the front of your book. Spearman rank correlation coefficient, and it is 1 minus 6 times the sum d squared over n squared minus 1. D is the difference, so we always need a column for our difference, but we also need to rank the things. Okay, so we'll do A for age, S for stopping, and let's rank the age. So let's do age rank. Let's rank the stopping distance, S rank. Let's say that the younger the car, the better. Okay, so if it's only 9 months old, that's going to have a rank of 1. It's better than if it's 15 months old, for example. That's the order it's set up for us, so we might as well follow what they've done. Same thing for stopping distance. The shorter distance that you can stop in, the better. Okay, so smaller numbers are going to have a better rank. So, first, second, third, not third, sorry, I missed one out there. We've got 35.4, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th. Now you can see, even when I put that on, that it looks like it's quite close to the other rank. Okay, it looks very, very similar. So actually that gives us a clue that it's going to have a strong correlation in Spearman's rank. Next column we need is D for difference. So we'll do AR minus SR, so 1 minus 1, 2 minus 2, 3 minus 7, 4 minus 4, 5 minus 6, 6 minus 3, 7 minus 5, 8 minus 8, 9 minus 9, 10 minus 10. See if they're lined up perfectly, gives you a 0, which makes this part go to 0, or closer to. Okay, so we're going to square them all. If it's a negative, it's still going to make a positive when you square it. And we don't have that many numbers, but when we do add those up, it's the sum of d squared. So it's 16, add 1 is 17, add 9 is going to be 26, add 4 is going to be 30. So let's drag our formula down. And let's put our numbers in. N is how many numbers you've got. So in our case, N is 30. N is 10. Okay. What I was thinking of there. 1 minus 6 times 30, that's what I was thinking of. 10 squared is 100, minus 1 is 99. So let's whack all that in our calculator. 6 times 30 over 990. That's going to give us 9 over 11, aka as a fraction it's going to be 0.8181 reoccurring, but we can just say 0.818 to 3 decimal places. Okay, is it going to ask us to comment? Describe and interpret your answer to part A. So our answer shows pretty strong, so relatively strong positive, because it's a positive number, correlation. So if we interpret that, what it means in terms of the data, it means if the car is younger, it's going to be able to stop quicker. So cars that are younger have shorter stopping distances. Okay, so that's what it shows in general. Not all the time. Okay, that's the answer. Question 13. A company making cookers finds the amount of sheet steel it uses each week is normally distributed, with a mean of 2,000 tons and standard deviation of 200 tons. Use this information to predict the maximum amount of sheet steel the company is likely to use in any given week. So we need to talk a little bit about normal distribution. We've mentioned many times about it being a bell-shaped curve like that, which is symmetrical, and bang on in the middle is your mean. And what is very important is how many standard deviations you go away from a mean. So just imagine that that gap is one standard deviation. If we go 2 standard deviations away from a mean on each side, then what we can do is we can think how much area we've got created. So think of this area inside here. Now the way that the standard deviation and the mean and the normal distribution are set up, every time this is 95% of your data. If you go one more standard deviation away, so if you go to 3 standard deviations each way instead of just 1 either side of a mean, then you've almost got all of your data. Okay, and this is actually always 99.8% of your data, which is pretty awesome. Okay, so 99.8% of your data. Now we're talking about numbers that we've got where our mean is 2000 and our standard deviation is 200 each time. So if we've gone 3 standard deviations away, then we're going to get to 2600. So the maximum amount of steel almost is going to be 2600, which we got by doing 2000 plus 3 times 200. Okay, it's very, very unlikely that you're going to need more than that. In fact, if you want to know exactly, this is going to be 0.01% because it's 0.1% because it's symmetrical, and this is going to be 0.1% of your data, and this is going to also be 0.1% of your data because it's symmetrical. That makes up the full 100. So it's very, very unlikely that you're going to go over that. So you can just say almost all of the data is below 2600 because this is 3 standard deviations above the mean. And actually we can say exactly, because we know up here we've got 0.1% and down here 99.8%, so actually 99.9% of the data is below. Okay, so there you go, that's fine. This was a correction, so that's why you might see other writing instead of this now. The manager of the company decides to make a regular order for the same amount of steel sheets to be delivered every Monday. Work out a suitable amount of steel sheets to be ordered and give a reason. Well, like we said up here, 2000 is in the middle of all the data. That is your mean, your average. So that is a good idea of how much to have delivered each week, because sometimes you're going to use less, sometimes you're going to use more, but if you use more, then hopefully you had some left from last time, and if you use less, then you're going to have more left over for the time after. So over time, the average used per week will be 2,000 tons, and we can say if some is left over, it can be used the next week. Part C. Give one reason why the answer to part A might not be a suitable answer to part B. So 2,600. Well, because on average we're only using 2,000. So on average you will have 600 tons too much each week. Which might get wasted. Okay. Question 14. Packets of nuts conform to European minimum weight standard, E. The packets in the supermarket were marked as 250 grams E. That means, on average, 1 out of every 40 packets, that's 2.5%, weighs less than 241 grams. Assume that the weights of the packets of nuts were normally distributed, with a mean of 250. So what we're looking at is the bell-shaped curve, as usual, and in the middle, 250. Work out an estimate for the standard deviation of the weights of the packets. So there's a point here on our curve at 241, and we know that here is only 2.5%. Now we know that if we're 2 standard deviations from a mean, that means that we have 95% of the data here in the middle, and that would be 2.5 here. So altogether 97.5. So that means that 2 standard deviations make up the gap between 250 and 241. So we're going to do 250 minus 241 divided by 2. And we're going to get 9 over 2, aka 4.5. The probabilities of buying 0, 1, 2 or 3 packets of nuts that do not conform to European minimum weight standard can be modelled by a binomial distribution. Greta buys 3 packets of nuts. Work out the probability that she buys exactly 2 packets of nuts that do not conform to the European minimum standard. Okay, so let's say that P is buying a packet of nuts that is below standard, which is, as we said before, 1 out of 40, because there is 1 out of every 40 packets, or 2.5%, so as a decimal, 0.025. That means the failure is 0.975, and if we're talking about exactly 2 packets do not conform, here I've called not conforming a success, so we want the 2 P's, so we basically want this section, so we want 3 times by P squared times by Q, 3 times by 0.025 squared times by 0.975. That is going to give us, on our calculator, 0.0182825, and we can round that to say 3 significant figures, and we get 0.00183, so 3 significant figures. Part C. This is the final question. In order to use binomial distribution as a model, an assumption is made about the probability that the weight is less than 241 grams for each for 3 packets. Write down this assumption. Well, about the probability, well, we've assumed that the probability stays the same, stays constant. Okay. That is the end of the paper, and thanks for watching, and good luck in your exam. Hope you manage to achieve maths. Goodbye.